Hi guys, today I'm going to show you how to construct a deep neural network model in Python. So in order to construct a deep neural network model in Python, we need to have two important softwares. First one is the Python and the second one is the Anaconda. Python is the language and the Anaconda is the platform. So I'll tell you how to download. You just go to the python.org website. Then you can see the executable installer. You just click it and download it. Then go to anaconda.com. You just download this Anaconda software. Once you download and install it, you just go to search option, then type it as say Anaconda. Then you can see the Anaconda prompt. You just open it. So here we need to create one particular environment for installing all those library files. So for that we have to type one command, that is this is the command for creating an environment, conda create environment tensorflow environment tensorflow. So just copy and paste it here. So we can rename it as TensorFlow environment 10 or 5 or something like that. Just put enter. So the environment is creating. So once we created this environment, we need to activate it. So there is one command is there for activating the environment, conda activate TensorFlow environment. So it's asking me to download some files. I already download, so no need to download now. So I put enter no here. Then I'm going to activate the TensorFlow environment. So conda activate TensorFlow env10. So automatically once the environment created, automatically it activated. So now I am closing this command prompt, Anaconda prompt. Then go to this search option. You can see Anaconda navigator. Just double click it. The navigator will open. You can see some icons like Jupyter, Qt console and spider. So here we are going to use the Jupyter notebook for writing the Python program. So before that we need to install that Jupyter notebook. Just click the install button. Once it installed, you just launch this Jupyter notebook. So if you double click it, it will launch in Microsoft browser or Google Chrome. So it's the notebook, Jupyter notebook is launching here. So now you can see a localhost. So here is the developing environment is there and the program also is there. I already developed one program in the name of video.ipny. ipny is nothing but Python notebook. Just you double click this program. So it will open in a new tab. So this is the program which I created earlier. So this is the deep neural network, simple deep neural network model. So if you want to generate a new Python notebook, just go to this file, new Python 3. Then you can see a new editor. Just you can type the program and you can save it. Any one of the name, new program. So all the program is saved in where we install that library files. So where we install the library file means go to C, go to users, inside the menu you can see the programs. So video.ipny, new pgm ipny. So here also you can see the Anaconda 3. This is the platform we installed here. So inside the Anaconda we can see the ENVS environments. So here already I have some environments like an ENV2, ENV2. So this is the TensorFlow environments. So when you activate these environments in the Anaconda prompt, automatically the library files is download in the particular folder. So now you are opening the program video.ipny. Now I am going to run the program. You just watch it. Go to cell, just click run all. Once you click the run all, it start to run. You can see a symbol in the right side, Python 3. The color is changing to red inside a hole. Now the program is started to run. Before that, I will tell you how to create the dataset and how to pre-process it. So first, to open the folder where we installed the Anaconda and Python. So here only we installed C program users maybe. So in here you have to generate one folder in the name of dataset. So I already generated that folder. You can see it here, dataset. So inside the dataset, I'm keeping just 20 images. First 10 images are normal samples. So what type of neural network we designing means, we design a simple neural network which is used for classifying the fundus images, whether it is normal or abnormal, like that. So I'm taking 20 images. From 1 to 10 is a normal images and 11 to 20 is abnormal images. So just create one folder and name as a dataset. So again I created one more folder as resized. So resized folder, just create one more folder and rename as a resized one. So if you generate this folder, once the dataset image is processed, automatically it resized and it's stored in the another folder. Name is resized one. Now the program is started to run. The epoch is going on. In meantime, I will explain the program how I designed the network. So first we need to import all the library files from the keras, that layers, flatten, convolution, max pooling, everything. Then numpy, matplot, everything we are just imported. It's already predefined library because we already installed the keras. If some toolboxes is missing means you have to download, you have to install it. And if you want install means anything new library files if you want to install means just put pip install keras, otherwise Tensorflow, otherwise matplot library, like that you can install it. So I'll explain the program. After importing the library files, we are generating two paths. Path 1 is the original image dataset path and the path 2 is the resized path. So in resized folder we can see the file is resized as 128 into 128. Then we are reading all those images from the path 1. Then after resizing it, we are writing all those files in the path 2. Then we are converted to array files and the resized one. Also all the images are taken as in the form of matrix. So once we read the dataset images, we are just labeling on those images. So I put 0 for normal images and 1 for abnormal images. So I have taken 10 samples for an abnormal images, 10 samples for a normal image. So I put 0 for normal samples and 1 for abnormal samples. So taken as a, so these labels and dataset taken as a single variable train data. Then it's converted to matrix format. Now the data processing is over. Now we are going to construct a neural network model. So initially putting the initial commands, patch size, number of classes, number of epoch, number of filters, pooling size and convolution kernels. Then we are splitting our training data into training and testing. So 0.2% is taken as a test size. So we reshape it for our required size, then displaying the training and testing data. Here only we are going to construct the deep neural network model. So sequential model, first model is equal to sequential of, there we are constructing the layers, convolution layer, 64 number of filters, 3x3 kernel, activation is ReLU. This is the size of the input, 3 into 128 into 120. Then second layer is the activation, third layer is adding this layer. So first layer is convolution, second layer is ReLU, and the third layer is convolution, fourth layer is ReLU, and the fifth layer is the max pooling. Likewise, we created one small network as 64 number of filters, again 64, and again 128 number of filters. Finally, using softmax classifier, with the help of cross entropy, we are classifying the fundus image, whether it is normal or abnormal. So after that, once we created that network, we are going to train that network. So here we put the epoch as 20. So 20 times we are iterating again and again for the full data sets in order to increase the accuracy. So this is the training. Here we are giving the training data and corresponding the layer, patch size, corresponding the layer labels, and the patch size and the number of epochs. So once you created this one, automatically the training starts and it will process over the training images. 80% for taken as a training and 20% for taken as a testing, and provide the result accuracy like that. So if you see the outcome, the training is now completed. I have given 20 epochs. So now you can see the images and the ROC and the existing and proposed system graph. So I put it for 20 epochs. The first epoch, the accuracy is 0.43 and the loss is 0.7. So when you increase the epoch, the loss will be decreasing, automatically the accuracy will be increasing. So we can see the final graph for accuracy, existing and proposed system, and the proposed system t-cap. The proposed system nothing but diabetic retinopathy classification only. Also here I used one more method which is used for comparison, that is the SVM method, support vector machine classifier. So I compare with the support vector machine with our designed model. So this is our designed model. Likewise, we can use it for complex model like Alex or transfer learning network like AlexNet, GoogleNet, VGGNet. Just I created a simple network for 64 layers. So once you run the program, automatically it's separating the training data and testing data and provide the result. So before running the program, you need to make sure that whether all the library files has been installed or not. Otherwise you will get error. Then use pip install and you can install that things. So you can install here also. If you want to create a new cell, means you just click this plus button. You can see you can create a new cell. Then you can see here pip install keras. Then control enter. So automatically the keras will install here. Also here we use the keras model only. Keras is the front end and the TensorFlow here is the back end. The TensorFlow is the back end and the keras is the front end. Keras is the simple open source deep learning library. We can use easily. We can use it directly. We can call all the layers and functions. We can easily train this one. I hope you understand the program and you understand the concept and how to download and how to install the Python and TensorFlow and how to make a program in the Python for classification problems. So I hope you understand. If any doubt means you can ask me, you can contact me, and you can text me and you can WhatsApp me. Okay, thanks for watching. Thank you.